Hello, this is 8.2, graphing absolute value functions. So absolute value is written as x with the bars around it, and what this means is the distance between x and 0 on the number line. And since the distance is always positive. So, for example, you don't ever say I ran -3 miles, right? Like I went for a -3 mile run. No matter which direction you go in, the distance is still the same. That's absolute value. So since, for example, 5 and -5 are both 5 units away from 0 on the number line, absolute value of 5 is 5, absolute value of -5 is 5. Another way of thinking about absolute value is like a shower for numbers. So if your number is dirty or negative, it goes in the shower, it comes out clean, positive. If it's already clean, it stays clean, or positive. So as far as this parent function, f of x equals absolute value of x. If we fill in the table, absolute value of -4 is 4, because it's 4 away from 0. Absolute value of -2, 2. 0 is 0, because if it's no distance, it's no distance. There's not a positive or negative issue there. 1 is 1, 3 is 3, 5 is 5. Now if we plot this here, -4, 4, -2, 2, 0, 0, 1, 1, 3, 3, 5, 5. If we connect here, there's our graph. So our vertex in this case, or where it begins in the center, is 0, 0. Our domain is -infinity to infinity because any x value can be plugged in. Our range, starting from the bottom here, we start at 0. That's included because there's a point there. And we go to infinity. For n behavior, as x goes to infinity, f of x goes to infinity, and as x goes to -infinity, f of x goes to infinity as well. For this example here, if we think of the general formula for these functions, it will be as follows. F of x equals x minus h plus k. This is very similar to, or this is almost the same as square root functions as well as polynomials. In this case, since it's actually like two lines combined, we end up with the slope out front here too. But in this example, it doesn't make too much of a difference. So our vertex here, since x plus 3 can be looked at as x minus -3, our k is -3, and that our h is -3, and our k is right here, -2. So we can plot that. Our domain, always -infinity to infinity for absolute value functions. If we graph it here, so our slope is actually just 1, because there's an invisible 1 right there. Up 1 over 1, up 1 over 1, and then the mirror image on the other side, up 1 over 1, up 1 over 1. So there is our graph. So our range now starts at -2, move down a couple, -2, that should be a square bracket, to infinity. Our end behavior is the same, it goes to positive infinity on either side. To the next page for example 2. This one is similar, except now we have a slope to contend with. So our vertex, our h is 1, because it's x minus 1. So our h is 1, our k is 2, for our plus 2 there. So let's plot that. So now our slope out front here is 1/2. So from here, we'll go up 1 over 2, up 1 over 2, and we'll do the same thing on the other side. So as far as the slope, whenever you get confused about whether you go up 1 over 2, up 1 which direction, know that if this slope is positive, it's going to be going upwards, so it's going to be a V. The domain in this case, -infinity to infinity. Range doesn't start till 2, included because there's a point there, and it goes till infinity. And behavior is the same, it goes to infinity as x goes to infinity, and it goes to infinity as x goes to -infinity. Okay, so here, somewhat similar. So the vertex, since this is x minus negative 3, our vertex will be negative 3 and then negative 2. So our slope in this case is negative 2 over 1. So when we had a positive slope, it went upwards. Now that it's negative, it'll go downwards, similar to parabolas and how they work as well. When your A coefficient is positive, it's going upwards, making a U, and when it's negative, it goes downwards, making somewhat of an N shape. So let's plot our vertex, negative 3, negative 2, and then we'll deal with our slope, down 2 over 1, and then the mirror image. And we can connect those. So now our domain, as with all absolute value functions that we'll deal with, negative infinity to infinity. Our range actually goes from negative infinity and then stops at negative 2, and it's included because there's a point there. So now as x goes to infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x also goes to negative infinity. For our final example, we'll write an equation for the graph. So first we find our vertex, which is 2, negative 3. We look for our slope. So to get from the vertex to another point, we'll go up 2 over 3, so 2/3. So this is another instance. If you're thinking, is it 2/3, is it negative 2/3? Since it's going upwards, it's going to positive infinity on both sides, we know we have to have a positive slope. So now our equation, g of x equals 2/3 times the absolute value of x minus 2 minus 3. Thanks a lot. Have a great day.